Welcome back. Today what we're going to be learning about is factors and multiples of a number, and also prime and composite numbers. The learning goals are I can differentiate between factors and multiples of a number, and I can identify prime and composite numbers less than or equal to 150. Differentiate just means being able to tell the difference between two things. So factors and multiples, I can tell the difference between the two of them. So let's get started. Factors are whole number multiplicandins that can be multiplied to get a specific number. So we're going to try to find the factors of 12. So we need to find the whole numbers that can be multiplied in order to get 12. In order to do this, we need to know what the math facts are for 12. And oftentimes we use something called a factor rainbow to help us. So in order to use a factor rainbow, we start by writing down 1. 1 is going to be a factor of every number. And obviously 1 times 12 gets us 12. 12 is an even number, so that means that 2 times a number, which is 6, can also get us 12. And finally, 3 times 4. Notice how I kept going between 1 through 12. I went from 1 to 2 to 3 and found their corresponding other number that will be multiplied to get to 12. Oftentimes we try to draw a rainbow to show that these numbers are connected. Just like this. I want you to pause the video at this point and try to create a factor rainbow to find the factors of 36. Hopefully your factor rainbow looks something like this. So we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Notice how when we have a factor multiplied by another one of itself, like we have 6 times 6, the factor rainbow just takes it from the 6 and goes back to the same number. Now, numbers that only have 1 and itself as factors are called prime numbers. An example of this is 17. 17 is a prime number because the only factors for it are 1 and 17. Now, numbers that are not prime, that is, have 3 or more factors, are composite numbers. So those were like 12 and 36. Both of those had 3 or more factors, so they are composite. Now, some of you at this point might be asking, what about 0 and 1? Well, 0 and 1 are neither prime nor composite. 1 has only one factor, so it's neither prime, and it doesn't have 3 or more, so it's neither composite. Same thing with 0, because 0 can be divided by any number. So I want you to take a look at this list of numbers. We have 92, 93, 129, 141, 145, and 113. Which ones are prime and which ones are composite? So let's try to figure out, first of all, which ones are composite. Obviously, any even number is going to be composite because that means that it can be divided by 2 and has 2 as a factor. So this is going to be composite, and that's the only even number that we have. Take a look at the rest of them. We've studied about divisibility rules. We see that we have a 93 right here. If we use our divisibility rule of 3, we find that 9 plus 3 is 12, which is divisible by 3. So that is going to be a composite number as well. The same thing applies to 129. 1 plus 2 is 3, plus 9 is 12. What about 144? Is it divisible by 4, 5, 2, 12, 10? It's not divisible by any of those. It's also not divisible by 7, and you also don't know any math facts that get you 141. This one is going to be prime. 145 is going to be divisible by 5, so that is going to be composite. 113, again, we don't know any math facts that get us 113, and it's not divisible by 3, and it's not divisible by 2, or 5, or 4. So this is going to be prime as well. I want you to take a look at this list and try to identify the prime and composite numbers in here. Using our divisibility rules, we can take out any of the even numbers such as 88, 122, and 146. We can also take out 117 because it is divisible by 3. The other two, 91 and 139, are prime numbers. Now, a multiple of a number is the product of that number and any other whole number. The multiples of 15 are going to be 15, 30, 45, 60, 75, 90, 105, and so forth. Notice how the smallest multiple of a number is itself. It's 15. Okay, it does not start with 1 as sometimes lots of people like to do. It starts with 15. So now I want you to pause the video and try to find the first 6 multiples of 12. When we count by 12s, we find that the first 6 multiples of 12 are 12, 24, 36, 48, 60, and 72. Now, a significant amount of people have a hard time remembering the difference between a factor and a multiple. Now, one way to remember it is that there are very few factors. Every single number has only a certain amount of factors. However, there are many multiples. You can count by 2's up to infinity and beyond. Okay? There are many multiples. You can count by 3's to infinity, you can count by 4's, you can count by 20 to infinity, you can count by 25 to infinity. So there are an infinite amount of multiples. At this point, please open up the Google form that is attached with this video and try out some of the problems that are in there.